All right, good afternoon. My name is Jason Morris. I'm here to talk to you today about ACES, our automated configuration engine for simulation. This was developed by my company, Agile Cyber Systems, based in Los Alamos, New Mexico. So overall, here's what I'd like to chat with you about a little bit today. I'd like to give you a little bit of an overview here. We want to talk about the objective of our solution, our proposed approach, kind of describe that to you a little bit. An overview of our simulation. We'll do the actual demonstration in and of itself, and then we'll do a little bit of a wrap up at the end with some concluding remarks and some future thoughts on where we can go with this system out here. So overall, our objective with this system, we wanted to do a few things. Number one is check the environment connectivity out there for both Windows and Linux hosts, as well as any kind of networking appliance or anything like that. We want to perform ports and protocols checks. We want to correct any kind of config file mistakes out there. And we also want a system that can be scalable as well. Now, ACES in and of itself can do way more than just these few things here. We just picked these out for the sake of demonstration here today, and hopefully that'll be enough to kind of show you the capability of the system and where it can go to from here. So I think you'll really like it. It is a pretty stable system, and we certainly enjoyed putting it together. So our proposed approach was to use a Java dashboard combined with the Ansible automation platform. Ansible has been around for about a decade, so we are reusing that technology. It's very well known out there in the technology world, and it's something that's very handy and enables us to get across to both Windows OSs, Linux OSs, as well as network OSs as well, iOS, and some of the others out there that we might need to do. So Ansible is very prolific throughout the environments out there. Excuse me. Some of the assumptions we made today for our sake of our simulation, we assumed we were going to have a Red Hat Enterprise Linux type system, as well as a Windows environment. So we're going to have both of those OSs out there. We also assumed that the HLA configuration files are going to be text-based, XML or something along those lines. So we just used a regular text file today for the sake of demonstration. The required software for this system is Python 3.6, Ansible Core 2.4 as a minimum, and then for the Windows host, they have to be running .NET 4.0, PowerShell 3.0 at a minimum, and WinRM as well. And there is a special PowerShell file that is used to configure those hosts to take a lot of those steps out. So for our simulation overview here, we have one controller, which is basically just a virtual machine running Red Hat Enterprise Linux 8. And then we have two hosts. One of those hosts is running Windows 10, and the other host is running RHEL 8 as well. The ACES system is agentless, so there is no software that has to be loaded on external systems. The only software has to be loaded on the main controller system in and of itself. And configuration management is accomplished using SSH over port 22 and WinRM via port 5986. WinRM is for the Windows host, and the port 22 SSH is for any kind of Linux host out there as well. We can connect to different systems via different services as well. If we need a console or anything like that, that can also be done through Ansible as well. So a lot of versatility here with Ansible. We really like it, and we think it's going to bring you what you need for a LVC environment that has a lot of different types of technology in it. You won't be bound having to build out a new system or reprogram anything. It all comes nicely and well packaged there. So the task we're going to demonstrate today, number one, we're going to check system connectivity. Then we're going to do a ports and protocols check. We're going to check the configuration file. And then we'll talk a little bit about some issues that we can fix automatically throughout as we can kind of build out some of this automation here as well. For checking system connectivity, just to kind of understand that a little bit. So basically with our system, we do a ping, but it's not your standard ICMP ping. It is a actual going out and connecting to the system via a port and making sure we have good two-way handshake for any kind of connectivity out there. So whenever we say connectivity or doing a ping, that's what we mean. It's not just your standard network ping that you might be used to. For checking the ports and protocols out there, ACES is great at going out and checking specific ports, seeing what's listening on it. If it finds something that's not listening, it can turn that service on to start it up and get it listening on that port as needed out there as well. For configuration file checking, basically we've just got a text file. We do a checksum to compare the files. If there's a difference in the checksum amount, then we know we've got a difference in files, and we go out and we overwrite the file. In this case, that is all we've done for this demonstration, but we can get more granular with that using an actual XML file where we can change individual XML elements so that you don't have to just overwrite the entire file. You can just change one small thing if you need to. That way it reduces the possibility for problems out there if you do a complete file overwrite. So with that being said, we'll move into our first simulation here for a connectivity check. So you can see on the left-hand side, we're pressing the button for connectivity check. The system's going to go out and check the Windows host and the Linux host, which are the small squares at the right-hand side there. The top one is Linux, the bottom one is Windows, and you can see both of those hosts are reachable. The unreachable equals 0. If unreachable equals 1, that means that the system isn't able to be contacted out there for whatever reason. So now we're going to turn on the firewall on Windows here, and we're going to make that host unreachable. We're going to run the connectivity check again. There is a timeout of about 30 seconds as it goes out and does those checks to see if it can connect to the Windows host. And if it doesn't connect in that time period, then just reports back that it was unreachable as well. In situations like this where a firewall has come up, unfortunately there's not much you can do. If you're shutting down all the ports, then basically you're going to have to call somebody and ask them to kindly turn off the firewall in that case. However, with ACES, if the appropriate ports are open, ACES could actually go in and change firewall rules. It could probably turn off the firewall for you if you wanted to do that. But you can see here we have unreachable equals 1 for our Windows 1 host. So you can see that the firewall itself was effective. So now we're going to turn that back off. We're going to hit apply on that, and then we're going to run the connectivity check one more time just to show that this is in fact showing accurately for reaching out to that host. And there we go. We're back to unreachable equals 0 for both hosts, especially Win1. So that is the basics of the connectivity check and how that works. Again, this is a solid port connection. This isn't just a ping. It's very effective to make sure that you've got really good connectivity with all of your hosts out there. This can scale up to do hundreds of hosts, even thousands if need be. Just based on the organization of the inventory file, we can filter what hosts we want to ping and check at certain times. So we have very granular control over the connectivity checks for our systems out there. So that covers our connectivity check, and next we will move into our ports and protocols check. So for ports and protocols, I've divided this out into Windows and Linux ports. So first we're checking the Windows ports here. So it's going to go out after we press that button, log into the Windows system, and it's going to check port 80 for us. In this case here, port 80 is down. I've turned off IIS on Windows, and we will show that here in just one second once it times out trying to find it. Okay, so there we go. Port 80 is closed. So now we're going to go into the actual host. We're going to manually turn on IIS. Again, this could be automated. If we don't find a service listing on a port, as long as we have access through the appropriate ports to that host, ACES can go in and actually turn on the service like we're doing manually right here. So here I'm turning on IIS. It is coming up slowly right there, as you can see. But again, this is a great spot for automation. So if you've got a listing of the types of systems you want listing on what ports during a large exercise, a large LVC type exercise, this system can go in and automatically check each and every host, make sure each and every host has the appropriate services listing on the appropriate ports. And if not, then it can go in and fix it. And that's a pretty remarkable thing. And it can fix it across any kind of host out there, regardless of if it's Windows, if it's Linux, if it's a network appliance, if it's a firewall, all of these things. It can cover all of them, and that is a very great piece of capability for this system. Okay, so we can see IIS is completely up, so we're going to check these ports again, and it will come up with port 80 is open here in just one second. And again, the goal here is to get more automated with the system as we go. So I look forward to getting some hopeful feedback onto what ports and protocols need to be where. And there we can see port 80 is open, and so we know that we have a good IIS listening on that system there as well. So I separated this out. Now we're going to check the Linux ports, and so it's going to go out to our Linux system. It's going to log into it, and it's going to check port 80 on that, see if anything's listening on it. So right now I started the HTTPD service, and it says port 80 is open because that service is listening out there. This system can also be made to list the services that are listening as well. So I stopped the HTTPD service. So we're going to do another check Linux ports button press here. And there we go, and it'll come back and say the system is stopped and port 80 is closed. So again, there are some ways we can make the system a little bit better by listing out the actual services that are listening on a port or not listing, and then we can see port 80 is closed, and it is working appropriately as it should. So this being said, whitelisting ports and protocols is a huge capability that we can do within ACES, and I think it'll be a big benefit for LVC type scenarios to make sure everything is configured correctly, that the right ports and protocols are talking to each other, and that everyone can talk appropriately within the system itself. All right, so with that being said, we're going to move into our HLA file compare and correction. Okay, so for an HLA file here, we have simulated that in our Linux and Windows host with a text file on both. I'm changing the text file on the Linux host here and saving it. Then when I do the same thing for the Windows host, I'm going to change that file up a little bit and hit save on that as well. This way we get a different file from the source file on the controller for ACES there. So closing that out. So here we go. We're going to check the HLA file. So what this is doing is there's a source file on the control head there. It gets the checksum for that source file and it checks it against each of the Windows and Linux hosts to see if it's different. And you can see there the files are different as the system has told us. So that tells us that we need to go out and rebuild these files out there, rebuild these quote-unquote config files out there. You can see that it's the system is checked differently for Windows and for Linux based on their different file systems as well. So here we've hit the fix HLA config file. So it's going to go out and it's going to resave the file on each one of the different hosts. And we will demonstrate that here in a second so you can see the host, the file has been copied to the destination. So we're going to reopen this file on the Linux host here, and there we go. We can see we're back to normal on that file for the text. Then we're going to open up the file here on Windows and see that we are back to normal here as well. So this is a very important capability for watching your FOM or your HLA files, which are based in XML out there. We want to make sure that these files are correct. We want to do a good checksum to make sure everything's jiving appropriately. The nice thing about ACES is that we can go in at a granular level and change the individual elements within an XML file. So we don't have to change the whole file. We can change one part or piece of it. So if there's a radio frequency, if there's a radio type or something like that that needs to be changed, that can be updated pretty easy, just one little element at a time, not changing the entire file in and of itself. So that takes care of the HLA file correction. So we will get into our conclusion here. So again, my name is Jason Morris. I've been involved with cybersecurity and IT for a number of years. I actually worked live virtual constructive in the Air Force before I retired in 2017 at the Distributed Mission Operations Center at Kirtland Air Force Base in New Mexico. So I'm pretty well familiar with live virtual constructive, what goes on, what needs to happen. Our system here with ACES provides a ton of capability when it comes to doing automation and for doing configuration file checks, for basically checking any kind of configurations out there, whether they be on a local host, Windows, Linux, network appliance, iOS, any of those things. ACES can get into them and can actually run those systems and make sure that they are configured and working correctly. So thank you very much for your time today. I hope this answered all of your questions. And please let me know if you have any questions as well. Thank you and have a good day.